Hi everyone, welcome to Javatechie. So today we are diving into a powerful feature of Spring Boot that can significantly enhance the performance of your application asynchronous calls using the async annotation. Okay, alright. If you have ever wondered how to boost the performance of your Spring Boot application or make certain tasks run in the background, then you are in the right place. So without any further delay, let's get started. So before we jump into the code, let's quickly understand the importance of async feature in Spring Boot. So let me walk you through a real-time use case. I assume everyone has used an e-commerce application to place an order. But do you know how the entire order fulfillment functionality works and what steps are involved in the processing a single order? No worries, let me give you a high-level overview of this order fulfillment process to demonstrate the async use case. Okay, so if you observe, I have considered few services here. Once an order request comes in, the purchase order service will check with the inventory service for product availability. If the product is available, it will proceed with the payment process. After completing the payment, it will notify to the user about the order and payment. Next, the order is assigned to a vendor. The vendor picks the order items from the warehouse and packages them securely. After packaging the order, it will assign to the delivery partner. Okay, so the delivery partner is responsible for transporting the orders from the vendor's warehouse to the customer's address. Next, following this, the delivery partner assign a trailer and dispatches the order to the customer address. So this entire process is known as the order fulfillment process. Okay, so just keep in mind that what I have explained in this presentation is just a high level overview. In real time, it usually involves numerous steps, so don't consider this flow as the source of truth. For demo purpose, I have selected a few known services that will help us to sync with the concept. Okay, so to complete the order fulfillment process, we need to go through many steps which could be time consuming. In real time, each of them could be a microservice. As you know, in the microservice world, each service need to communicate with others either to get a response back or to send the input. So if you observe in this workflow, the purchase order is the one microservice that needs to call other service to complete the order fulfillment process. Since the order service needs to make HTTP call to the others, each service will definitely take some time to respond. Let's consider some random response time. It can be less or more. So just assume this number. Okay. Now if you observe, the overall service call took 8 hours or more. That is expected, right? As it needs to go through so many steps. Now the question here, will my user wait for 8 hours to just get the response saying that okay, your order has been placed? Definitely not. If that's the case, no one will use this kind of e-commerce application. Then what is the solution? How can I convince my user? It's very simple. Once the payment process is done, immediately give a response back to the user with some tracking ID or transaction ID. Let the rest of the flow execute in the background, okay, in asynchronously. Since you have shared the tracking ID or transaction ID with the user, they can happily track their order to get the updates, whether the order has been dispatched or what is the state of the order. Okay, but how can I design the asynchronous process? That's where the Spring Boot provided @async annotation to deal with such kind of scenario. So until the payment processing, you can make the synchronous call. Rest all the services like notification, packaging, assign the vendor, assign the delivery partner, dispatch the product, all rest of the services you can perform or you can execute them in the background using asynchronously. Okay, that is the scenario where you can use the @async annotation given by Spring Boot. That's awesome, isn't it? So let's get our hands dirty with the async concept with the same use case. So let's go back to our ID to demonstrate this particular code. So to save our time, I have created a small POC. I'll walk you through the code, then we'll understand how we can enable the async in Spring Boot. So let's go to the pom.xml. So the version of Spring Boot I am using 3.1.5, and I just added the web dependency and Lombok dependency. Okay, nothing else. Fine. Now let's go to the service. So I have created a service called order fulfillment service, and if I'll expand this for you, you can clearly see the steps what I have discussed in the presentation, right? Inventory service, process the payment, notification service, assign the vendor, packaging, assign the delivery partner, dispatch the product, and assign the trailer. Okay, these are the steps. So just what I have done here, I have created a method called process order. So something I am setting the tracking ID in the order response. Okay, because I am using the same as a input and response. So I have set the tracking ID. Then simple step as per the presentation, this purchase order first check with the inventory service. Then if the product is found, then it will just process with the payment. Okay, so if you observe in the code, what I am checking, if the product is available in the inventory service, so I didn't write any logic, I have just written the true and false. Okay, so rather than writing these services in the same project, this should be a separate microservice. Since for the demo purpose I am just writing it here only. Okay, but to understand the async flow in real time, you could create a separate service called inventory service, and you can write the actual logic. Here I am just returning true because this is the demo. I want to show you the asynchronous call in this particular workflow. So that's fine. So always it will give you the true. So once the product is available in the inventory service, then we are processing the payment. So if you observe again, in the payment service, I have written the process payment method. This I have created a separate service, but in the microservice, it need to be a separate microservice. Okay, and here I don't have any logic, just added the log statement, and the process payment might take some time. So intentionally, I am blocking the thread for 2 milliseconds. Okay, so this there you should write the actual code, not this one. So since it is the demo, to make it easy for you, I have just defined different service. Fine. So if product is available, then process the payment, else throw some exception. That's fine. This is what I want to execute in synchronous. Okay, so if you understand the workflow correctly, if I will show you the presentation, purchase order, inventory service, payment service, these three interaction I want to perform synchronously, so that immediately after the payment is done, I can send the response back to the user. Okay, and this notification and other services I want to run in the background. So I have written the other services as well. Okay, so again I have written this as a method. You can create a separate microservice called notification service, and you can write this notify user by email or SMS. You can write that actual logic. So here I have just defined the method notify the user. See, very simple guys. Each and every services I have defined as a method here. Fine. Notify the user, and it will block the thread for 4 milliseconds and notify the user. Then assign the vendor. I have added the log statement. Then packaging, assign the delivery partner, assign trailer and dispatch. All the steps that we have discussed in the presentation will be in the same flow. Okay, now what I am doing, I just call this process order method from the controller class. If I will expand this, all the services we are calling from the controller. Process the order, then notify the user, assign vendor, packaging, delivery partner, assign the trailer and dispatch. Everything I am just doing here. Okay, but what is our goal to do? Up to this process order, I want to execute it in synchronous mode, and rest all the services I want to run in asynchronous mode. Fine. So how I can perform that? So I will tell you in a moment. But before that, first let's check the default behavior without implementing the asynchronous call, how this particular flow is behaving. Okay. So simply I will start the application. There is no other logic guys. Okay. I have created this service, then DTO, that is order, and controller. So this is the simple steps. For the demo purpose, I have just written the SOPLN statement. So let's wait it to complete. Yeah, it started. Now let's go to the postman. What I'll do, I will just minimize this so that you can see the response in the console. Now let me trigger the request. Okay, I need to keep this side. Can you see here? Initiate the payment for order, complete payment for the order, then notified to the user. Each and every steps is getting executed, but we are not getting the response because my entire main thread is blocked to complete this process. Still we are implementing, not implementing, still we are using the synchronous flow here. Can you see here? Whatever the thread blocking we have added thread.sleep, it is taking that much time to complete the task, and then we are getting the response. It took 26.49 seconds. Okay, now if I'll trigger again, it will initiate the payment for the order this, then again it will take time to complete all the steps, then we are sending response to the user. If that is the case, then it's not a good practice to implement, right? Because this notification service or assigned vendor service, packaging service will definitely take some time. And if you observe, the entire flow is executing with the single thread, that is the main thread. Can you see here? HTTP NIO 9191 EXEC3. All the steps or all the flow is executing by the single thread, and it's blocking the main thread. That is not the good practice to implement if you have such complex scenario. Then what we can do? So as we understand in the presentation, let's make this purchase order inventory payment service by default synchronous, and rest all the service I want it to be execute in the background without blocking my main thread. Let them initiate a separate thread and let them execute in the background. Okay, how I can do that? Very simple. That is the reason we need this async annotation given by Spring Boot. So we'll go step by step to understand how we can enable the asynchronous flow here. Okay, so the first step, we need to create our own thread pool. Okay, because I don't want my flow to block the main thread by executing in a single thread, so I need to create my custom thread pool task executor. If I will not create that, then by default, if you enable the async in your Spring Boot, by default Spring Boot will create simple async task executor, okay, with the default configuration. Now you have the option to create your own thread pool task executor by defining what is the number of core you want to use, what is your queue capacity, how long your task can be present in the queue, what is the max pool size. Lot of things you can customize as per your use case. So rather than relying on the default task executor given by the Spring Boot, let's create our own thread pool task executor, okay, so that we can play with the thread. So for that, what I can do, I will just create a class here inside this config package. Let's name it async task executor or async configuration. Just annotate this at the rate configuration. Then simply just create a bean of executor by creating the thread pool task executor object. It's very simple step. Public executor. Then simply define a method, something like async task executor or something like that. Then just create the object of thread pool task executor. Fine. Now in this task executor, you can define the core pool size, queue capacity or max pool size, those many things. Okay. So let's write task executor dot set core pool size. Here I am setting the core pool size to the 4. These threads are kept alive even when they are idle. Okay. Now I'll just define task executor dot set queue capacity. I'll just define the queue capacity to 150. So what it will does, it will set the maximum number of tasks that can be held in the queue if the queue is full and additional tasks are submitted. Let's say queue is filled with the 150 and 151 tasks came, then it will trigger the creation of the new thread up to the maximum pool size what you will define. Okay, task executor dot set maximum pool size. So I'll define it to the 4. So what this max pool size does, it sets the maximum number of thread that the pool can have if the queue is full and the maximum number of thread has been reached. So we have defined the 4, right? If there are so many tasks which is not splitted by this 4 thread, then those additional tasks will be rejected. Okay, so these 3 are the key configuration for concurrent execution. So you need to define based on your core pool size of the VM. Okay, that's fine. Now just define some prefix task executor dot set prefix, something like that. Set thread name prefix. Okay, I'll define something like async task thread, so that this will be act as a prefix. Once you have done with this, then you just need to initialize your task executor. Task executor dot initialize, then just return it, and just define this as a @bean, and you can define your name of your bean, something like async task executor. Just copy this. I just want to define my bean name. This is optional, okay, but I want to define this bean name so that I can tell to my Spring what all method can be used this particular configuration to execute asynchronously. Okay, next we need to tell to the Spring Boot that please enable the asynchronous method execution for me. So for that, there is an annotation given by Spring Boot, enable async. We can use this annotation to enable the asynchronous method execution. So once you have written this particular annotation, Spring Boot will internally search on top of what method we have annotation called @async. Those methods only Spring Boot will execute asynchronously. So I will show you that how you can define that annotation as well. Let's go to the order fulfillment service. So this particular, as per the flow, purchase order, inventory service, and payment service, this flow I want to make synchronous call. So I am not going to modify these three services. Okay, only rest of the services I want it to be executing asynchronously. So we have enabled the enable async to tell to the Spring Boot, please enable asynchronous call for method. For which method? Wherever you are finding this annotation @async. Okay, and define what thread configuration it will use. That is what the bean we have defined. Fine. Now rest all the method I want it to execute asynchronously, I will just define this. Once you added enable async annotation, then Spring Boot will look for this particular annotation on top of the method, and make sure wherever you have added this async annotation, that method return type either void or completable future. I cannot keep string here. Okay, even though if I'll define, it will give the exception. So always it will be either void or completable future. So if you have multiple tasks and you want to join all the task thread result and return it back to the user, then you can go for the completable feature. For now, since this is the demo, I have just defined void because we just want to understand the concurrent flow. Okay, and we'll verify which thread is getting executed each and every flow. Fine. So we are done with the configuration. Now what we'll do, we'll just test the application. So what we are going to verify, once the payment is done, it will notify to the user. So until the payment is completed, it will immediately give the response back. My thread will not block to execute all the flow. Okay, that is what something the purpose of using asynchronous, right? Once the payment is done, immediately I want to give the response back to the user, and rest all the flow will be executed in the asynchronous. I mean with the different thread rather than blocking my main thread. That is what we are going to prove now. That's fine. Let me start the application, and I will just minimize little bit so that we can see the proper console. So it started. Let me clear this. Now from the postman, I will trigger, just observe here in the console, when the payment process is done, immediately user will get the response, okay, with the tracking ID. Now let the other process will execute asynchronously with the different thread. That is what the goal I want to demonstrate here. So let's run it, initiate the payment. See here, immediately we got the response once the payment is completed. Okay, next it started executing other flow. Order packaging completed, notified to the user. It's running in the background, right? And you can see it is using the different thread. Task executor thread 3 for packaging, thread 1 for notification service, thread 2 for assigning the trailer, okay, assigning the vendor, right? And then 3 for assigning the trailer, and 4 for delivery partner. So we have defined the fourth thread, and all the fourth thread is executing behind the scene without blocking my main thread. Okay, so let me retry again so that it will be clearly visible. Just keep a eye on the console. Once the payment is done, it is not waiting all the steps to complete and giving the response. Once the payment is done, immediately we are getting the response back. Since all the rest other flow, we make it asynchronous, so it's running background. Okay, so let me run it again. See here, we got the response. Then other steps are getting executed in the background with the different thread. Okay, that is what something the asynchronous flow you can achieve in the microservice world by implementing this @async annotation. So I hope the use case what we have discussed here is the correct scenario to cover the async, and I hope you are clear with this particular use case and its implementation to understand the asynchronous flow. Okay, so do let me know in a comment section if you guys have any doubts, and you can give a try with different use case. Okay, that's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.